Look at the next topic. This is circular permutation. A permutation which we have studied before is an arrangement of objects uh, in a row. Now we will talk about the arrangement of objects in a circle or in a curve, in a closed curve, right? We will suppose that we have a circle like this, and we have to arrange our objects along this circle in this way. You can see here. So such kind of arrangements are different from the arrangements in the row. So we will talk about these kinds of arrangements. So first I will assume the simple case. First of all, I will let three objects A, B and C are three objects. So for this simple case, we will go further towards the circular permutation of n objects, right? Now we have three objects. After studying this case, we will go to the permutation, circular permutation of objects, of n objects, right? Okay, so we have three elements, A, B, C, and we want to arrange them in a circle. Okay, we will consider a table which has three chairs, but that table is circular. Okay, look at this table here. This is a circular table. Suppose it has this chair, it has this chair, it has this chair. So we have three chairs on this circular table. First assume that this is chair 1, this is chair 2, this is chair 3. We have three slots, and how many elements are there to arrange? There are three, A, B, C. Okay, first look number of arrangements. How many arrangements are there? Okay, all possible arrangements of A, B, C on chairs 1, 2, 3 are given below. First, make three circles, two circles. Okay. First, fix A at position number 1. Here again, fix A at position number 1. This is position number 2. Okay. This is position number 2. This is position number 3. This is position number 2. This is position number 3. You can see it is your table on which you have to arrange your elements A, B, C. We have fixed A on first position. So for the possibilities for B and C are, in the first arrangement, B will go to the second chair and C will go to the third chair. And for the other arrangement, B will go to the third chair and C will go to the second chair. A has been fixed in this regard. Now we can do the same thing by fixing here B instead of A. We will get again two different permutations. Then we will fix C. Look how it works. Now we have fixed B instead of A. You can see here. Here we have B. In the first arrangement, C will go to the third chair and A will go to the second chair. While in the second arrangement, A will go to the third chair and C will go to the second chair. Now we will do the same thing for fixing C. Now fix C here instead of A. Here we have C. You can see here we have C, the remaining elements of A and B. Okay, right here A and right here A. Okay, let me write it clearly. It is A. So how many arrangements you can see? This is first arrangement, this is second arrangement, this is third, this is fourth, fifth, sixth. But the question is, are are these arrangements are different from each other? We call this arrangement as first arrangement. Call this A B C. Move clockwise. Okay, I am going to move clockwise. Call it A B C, and call this clockwise again. Start from uh, A C B. Okay, again name this one. It is B A C, and what is this? Again move clockwise. It is B C A. What is the name of this permutation? This is C B A. Okay, I claim A B C, then B C A, then C and C A B represent the same permutation. I mean, either we arrange three people, the first one is A, second one is B, third one is C. If we arrange in a circular pattern in this way, or in this way, or in this way, they will observe no change. Actually, they will observe no change. How? How? If I prove that all of these permutations uh, can be obtained from each other only by rotation. Only by rotation. Let's look. This is ABC. This is again BCA, and this is CAB. I am going to claim that all these permutations, I have joined them with red. They are representing the same. Okay. You can see I'm going to rotate it anti-clockwise. What will happen? A will move here, C will move here, and B will move here. You can see this is the same thing which I have done in this here. You can compare. Okay. Now, how can I get 6 from 4? I can get after by rotating again anti-clockwise. If I rotate it anti-clockwise, B will move here. You can see this. A will move here. You can see this. And C will move here. You can see this. Okay. I have proved that all these three permutations are obtained from just rotating one permutation. Therefore, they will feel that we are sitting in the same pattern because they are obtained by the rotation of one permutation. Which one? A, B, C. Okay. Similarly, we can say that these the remaining three permutations also the same. So how many total permutations are there? Only two. Only two. The one is this class which are connected to the red line, and the remaining which are not connected to each other, they are also representing second class. So we have only two cyclic permutation, two permutations for three people. Okay. So hence there are two possible permutations. for three people or three objects, three people to sit along circular table. Okay, so what is the connection of circular permutation with the permutation, simple permutation, in which we arrange objects in a row? Now I will uh, write the formula. Denote it by 3q3, as I have denoted permutation by npr. Now I am going to denote circular permutation by q. Okay, 3p3 is 2. This I have proved in the previous work. So now I'm going to find the connection of circular permutation with simple permutation. You know, 3p3 is 6. Why it is 6? Because it is 3 factorial over 3 minus 3 factorial, which is 3 factorial over 0 factorial. You know 0 factorial is 1, which is 3 factorial, and 3 factorial is 6. You can see the connection of these two. You can see by comparing both, we can get q33 is obtained by 3p3 over 3. Can you imagine? If I divide 3p3 by 3, what is this? This is 6. If I divide 6 by 3, then I will get 2. This is my observation, that circular permutation is obtained by dividing with the factor of 3. Is it possible that, it's my question, is it possible that nqn is obtained by npn over n? Is it true? Okay, if is it true, it is true, then we have another question. nqr is related to npr by r or n. What is this? So my claim is this is true. My claim is this is true. So if I prove the second one, this one, then this one will be proved automatically, because in the second one I will replace r by n. The first one will also be proved. So I will prove the second one. Okay, look how to prove. Suppose that there are n total objects. We want to arrange r of them. We want to arrange r of them along a circular table. Okay, so look at the diagram below. I have a circle here. You can see, suppose we have r different objects. Let this is x1, this is x2, up to so on, x3, x4, up to so on, dot dot dot. Here you have, suppose, xj. Here you have xr, right? You have total r objects and you have arranged them along a circular pattern. Our aim is to find the number of ways in which they can be arranged. Okay, you know, in the previous example, first we had found that for 3 circular permutations we had total 6 permutations, and then we had divided by the number which are identical. Okay, what do I mean? The number of permutations which are identical. Okay, you can see from the previous example here, these three elements which are connected to each other, these are the number of permutations which are identical. Okay, so how did they obtained? They obtained by rotating first permutation clockwise or anti-clockwise. We have rotated it anti-clockwise. Someone can rotate it by clockwise as well. Okay, so first of all, we will rotate it clockwise. So call this permutation, let x1, x2, x3 dot 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 xr is the one arrangement. So I am interested in those arrangements which are identical to this particular arrangement. So if I move towards clockwise, first of all, x1 will go to x2, x2 will goes to x3, and then this element will move next, then next, then next. They will move next. In this way, it will move next. Then this element will move this, and xr will move towards x1. So then here I will have xr. So then other permutations obtained by rotation of this permutation clockwise or anti-clockwise. I am going clockwise. R. The first one is, how will obtain the first one? xr, then x1, then x2, up to so on, dot 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 xr minus 1. And what is the next one? The next one is xr minus 1, xr, x1, x2, x3, dot dot dot. Here you will have xr minus 2. And we will follow the same pattern unless we have here x2, x3, dot dot dot, xr minus 1, xr and x1. These are all permutations which are obtained by rotation of this one. Okay, this is 1, this is 2, this is 3, dot dot dot, and this is rth permutation. So r permutations are identical. They are obtained by rotation, therefore they are identical. So these are identical. Permutations are identical in a circular permutation. Therefore, they will be considered 1. Okay. So, therefore, the total number of permutations are NQR. It is obtained by NPR, but in our case, R permutations are identical in each case. In each case, R permutations are identical, so we have to divide the whole number of arrangements by R. This is the formula which we had to prove. So this is the formula for circular permutation. Okay. In the next video, I will solve some examples about circular permutation. Thank you for watching this video. If you have any question or queries, then you can ask me in a comment. I will respond you properly. Thank you.